Hi everyone, and welcome to another Codurance meetup. I'm Sebastian. I'm craft person at Codurance, and I'll be your host for today. The talk will be presented by Cameron, who is also a friend of mine and colleague at Codurance. We know each other personally quite good. And the main topic for today that we'll be covering is database refactoring, strategies for mitigating the risk and minimizing it, and how to evaluate what we need to do with the database. Quick reminder is that session is recorded, and in the next couple days we'll be uploading the session to YouTube channel. As the topic that Cameron will be discussing is quite heavy, the slides at some point might get quite beefy. So don't worry about making notes. The session, as it will be recorded, you can always refer back to it in next few days if you require. And always feel free to get in touch with us if you would like to continue this topic of refactoring database and how to handle this in the future if this session it's not enough for you. So I'll pass it to Cameron. It's all yours, man.
Cool. Thanks very much. Good afternoon, everyone. Welcome to Refactoring Databases with us at Codurance. So yes, refactoring databases, best practices to minimize risks and maximize benefits. As Sebastian says, it's a very heavy topic. It does depend a lot on what the individual business use case is. So we'll hopefully be able to cover some material that can be applied to anyone that's looking at planning an operation like this. So with that, we'll go ahead. So what is refactoring? I'm not going to go too deep into this. I'm sure most of us know what it is, but refactoring is, of course, the idea that we're going to be changing the structure of something and how something works without really changing what it does. And that's normally how we refer to it with a code base, which is what I feel like we normally are talking about when we say refactoring refactoring in general. And so in a similar way, we're going to be changing the structure of our database and changing how it works rather than the data inside. So it's more about ensuring that we've got a data storage solution there, which is easier to maintain, but isn't too intimidating when we're discussing the possibility of adding new features into the future, that we get a good, reasonable performance out of, and that we're making the best situation out of the resources that we have available to us. So the goal of this presentation is to get a good idea of what kind of strategy you can plan out with your team and with your stakeholders when you are planning an operation like this. It is a big operation. It's a big sort of scary operation, as you could imagine. Data is, of course, you've got for the most part, I would say, it's the most important part of a business, if not every time. The data is one of the most valuable things that you can have. So of course, when you're changing something, making amends to something that is really holding that data for you, things can get a bit scary. So this is all about risk mitigation, identifying the risks, identifying the business needs, and trying to make the best situation out of this intimidating operation, and hopefully make it a bit less so that it can be done confidently and with the fewest problems as possible. I should also add, regarding the purpose of this demonstration, I've already mentioned it to the early people that joined, but because it does depend so much on the individual use case, specific techniques and things like that, we decided to omit that for this session and focus primarily on things that can be applied to hopefully every sort of session of planning for a database refactoring. So speaking of that, the purpose of refactoring the database will be the first one up, and then we'll go over the risks. And then after that, we'll go over some mitigation strategies, which will help to lessen those risks. So first of all, the purpose of refactoring a database, because you need a good reason to do something like this. So the reasons for doing so, it's got some obvious ones. We've got improving database performance. As you might know, if you get some schemas which have been sort of thrown together without much thought behind them, you can end up with some very nasty and sort of messy queries that can be inefficient and take up more resources than that operation necessarily needs to take up. Reducing complexity, that's always good for anything as simple as newcomers to the project being able to understand what's going on and find out what's going on, up to the ease of working for a user story of adding a new feature, for example. It's always nice to have something which is easy to understand. Adding functionality, I've already sort of covered that with that previous point, and it's always nice to remove technical debt, as this with anything else is going to get worse the longer it's left. If we keep putting it on the back burner, it's only going to get more difficult until something eventually chokes and gives up. So those are 4 sort of purposes that we've identified here. And of course, with the purposes come some associated risks with trying to perform this. The risk of refactoring databases. Data loss is a big one. So, and it's going to be one of the scariest ones as well. Like we said, companies and organizations that do value their data extremely highly. And of course, depending on what kind of industry you're working in, if you're working in medicine, for example, or governments, organizations, this data can be tied into some very scary sort of legal ramifications as well. So of course, banking, of course, goes without saying on that list. So data loss is a very scary sort of risk that can, that's definitely worth considering. Application error goes without saying. If application hasn't been updated to deal with these changes, then that's going to break and it's just not going to work for you. Performance issues. Hopefully that you're going to be experiencing an uptick in performance with a good database refactor, but if something has carelessly been applied, or something has been done correctly, then you might find that it's going to get, you might find that it's got worse. And also with some of the, with a certain strategy that you might have to take, you might find that you have to take a performance hit during the operation, but we'll get to that later to see when that is an applicable business use case. Downtime. Downtime is applicable both. It can be part of your strategy if you choose to have downtime, but it can also be a risk of if something hasn't been done correctly, then naturally with like a lot of problems, if something is sort of fails in a big way, then you can expect for the system to go down or just stop being functional as well, which is definitely something to be concerned with. And incomplete refactor, if that's done in such a way that you have inconsistent state across the database, then of course that's going to be an issue as well. So yes, those are 5 of the main risks that we've identified when we come to doing something like this. So some very good purposes, some very good reasons for doing something as scary as this, but of course some very large risks associated with something like this, which can put off stakeholders and certainly make a development team very nervous. So the big question is, how do we get the benefits while avoiding these risks? And that brings us to our mitigation strategies. So the main, something that is very clear and to something that's this drastic is some clear plan of action. Hopefully we go into any sort of operation with a clear plan of action, but in this case, we really want to focus on the point that we need to have a clear plan of action from day one, involving both the business side of the business, the business side of the organization, the business people, perhaps the non-technical people involved in the organization are involved in the process from day one, as well as the technical focus, as you would do with anything technical. And this is where a big bulk of this is going to be discussed. So a business focus plan. So what we mean by that is we're talking about our non-technical stakeholders for one. We're talking about teams that might interact with our system during this time. Teams like the QA, for example, all these sort of people and the reasons surrounding a business, the business side of the conversation. So the first point to mention is we need to make sure that we have a business goal here. So have we identified what is the problem or what is the room for improvement, which is so much of an issue that it's called for us to have this discussion about, should we refactor our database? Should we go into this procedure? So the first point is we need to identify exactly what it is we're looking for. That could be, faster write times, or it could be maybe, especially in this era of cloud computing, is there any way, if we make our storage solution more efficient, or if we change schema, if we do these things, can we have a better solution up in the cloud regarding to cost, etc. So what is the goal here? What are we trying to do by making this database refactor? Another big thing with something that's this scary and it impacts the business this much is, of course, to have the QA involved from start to finish. So discuss it with them before you even, take what you might consider to be the first step. A lot of communication with QA. plan out a strategy with QA. In fact, like when we sit down and go, what would you identify as someone on the QA team as a strategy for us to approach this to ensure that everything is working as best as it possibly can throughout the process? The stakeholders, identify who they are. So these could be business heads, people on the business side who are going to be very concerned with potential side effects of this, like downtime or performance hits like that. And they will often have a lot of important information for the team when it comes to deciding when to do this, for example. So they might be more interested in performing this kind of operation when there's less traffic, when we know that there's less traffic, when we know it's a less busy time, for example, or perhaps there's a particularly less busy season for them where they prefer for this operation to be undertaken. And something that's worth mentioning with this as well, when we are talking about something that is this drastic and this sort of risky, is to have a very candid conversation with them from day one about, this is what we're looking at regarding risks. This is what we're looking at regarding benefits. It is a tricky decision to make, but we think it's worthwhile because of X, Y, and Z. And that ties into the discussion regarding the goals. What's our reason for wanting to do this as well? And they can be a great source of information for understanding what's the best way to approach this. And of course, involvement of stakeholders at all times, like I say. Prioritize risks for your business case. Like I say, so much of this depends so much on the individual use case that we have. So like I mentioned before, certain industries or organizations, sometimes their data is more sensitive than others. There are things like in Europe, for example, there's GDPR to be concerned with, like how visible can data be, which can be a question that your team might have to consider when we're talking about the mitigation of, the migration of data from one place to another. The observability of this data might have to be a question, especially if we're talking about the industries I mentioned before, like the medical side, government or financial. So there's a lot of questions there that have to be considered, as well as things like your technical stack. So, we have this particular database. What's the best way we approach it like this? A big question, which we'll see later, affects what our strategy could be in a rather big way, is can we afford to have downtime? And if so, how much downtime? Not only when we're strategizing how we can approach this refactoring, but also when we're talking about quantifying our risks and identifying how large the risk could be if we go about performing this operation. If it does go down, can we get it back up quickly, and how do we go about that? The other side of that coin is, can we afford a performance hit? Like we'll see later, these 2 points, they are involved in the strategy that we choose to go about a database refactoring. And again, how much of a performance hit? You might have a situation where a database is already kind of struggling, and it's something that needs to be discussed to see if it's really a viable option. The rollout plan, that's a big one. So again, this is involving everyone. You have to really sit down and think about the stakeholders and think about who is going to be involved and impacted by this, and really speak to them from day one. So this is, and it's also talking about, before, during, and after the event. So we're talking about at the beginning, we're identifying with people who are stakeholders and people that understand the certain aspects of this operations, like the QA team, for example. Sit down, getting the plan, discuss with them and get their input. Certain people involved will be very important to the process as it's going on. So like I say, those would be QA, they could be users, there could be, anybody involved in the organization that can be affected by this or involved. And then of course, at the end, for example, it could be something like identifying, how do we identify that this has worked correctly? Or what are our metrics to make sure that we understand that our database refactoring, we consider it finished now on the surface, but how do we really confirm that we've got what we wanted out of this operation and that we've really got some kind of improvement out of this, whether that be performance or a reduction of complexity or whatever it might be. And finally on here, a really big one is, what is our disaster recovery plan? We'd like to think that everything's going to go perfectly well with something like this. But sadly, sometimes, no matter how much effort we put into doing things the right way, sometimes something unexpected might come up, like a blind spot might come up, and we get to that point where we have to roll things back in order to get back to where we were and get back to a point where things are working correctly. So what kind of plan do we have? Do we have a backup system here? Not only just talking about getting the backup done, but we're talking about how quickly would we be able to get back to our functioning state, which goes without saying, something that a lot of the stakeholders are going to be very concerned about. If we're talking about a business that's running, or something that's quite a critical system going down, and we get into a messy, problematic situation, they're going to want to know how quickly we can get back to a working state. I feel like I've been speaking for an awful long time. If anyone does have any questions, I can't see the chat at the moment, but my mouth's getting awful dry, so now would be a great time to ask any questions if you'd like. If there are any, or if Sebastian, if you spotted any in the chat.
No, chat is empty.
Okay, cool. And I shall continue.
If you have any questions, go. Feel free.
I guess it came to mind while you were talking about this. If an organization isn't used to this kind of planning for the worst, have you? I guess there's two questions I can ask here. One is about your personal experience, but the other is how might you show off this line of planning without it sounding like you're expecting for everything to go wrong? Because I can imagine that might be a potential criticism.
Yeah, well, to be honest, I think that question, you can apply that to really things outside of this. I mean, this is a very particularly scary operation, but there have been other times where it's simple things like and you can really apply this to things as silly as like a small refactor of a particular service somewhere. You keep saying like, this is a big deal because it might not seem really important to you right now, but this is going to be something that's going to seriously affect lead time, for example, or something like that. And they might want to put it off for a bit. And then one day down the line, there'll be something where they experience the problem, they're annoyed by it, and you kind of want to say like, well, we said,
yeah,
that's a thing. And I think it's kind of in the same realm of conversation as that. Unfortunately, one of the sides is, as I'm sure you will already know from personal experience or just understand from common sense, is when we are talking about something that is this drastic or this scary, like you have to tell them the worst case scenario, because God forbid it happens, then there's some saving grace in the fact that you are honest with them from the beginning. And it is, after all, their business in a lot of cases, or their organization. So at the end of the day, as obvious as it might seem to us as the technical team that something needs to be done, and it will be done easier sooner rather than later, that's just the universally recognized fortunate side of our job, is having to win that conversation. I suppose the only thing I could think of is when you do deliver this, the bad news, like this is how scary this is going to be, is also really highlight, when we get this done, we're talking about saving these costs, or we're talking about things being done this much quicker, so yeah, unfortunately, I think it's just that same consultancy question of how do you convince people who don't, because they're so concerned with other business related problems that they don't maybe pay credence to really the severity of certain technical concerns. And that is the let me know when you figure it out. That's the $1 million question. So
fair enough.
Yeah,
thank you.
No problem. I don't feel like I really gave a
I think it was admittedly a very difficult question, because if someone were to kind of ask frame something like that, I think we probably agree that they'd be being a bit difficult, in the sense that it just needs to be done right, and it's responsible to plan for the worst. So yeah.
And there's also another way to look at things, technical and otherwise, which is we talk about the risk of what happens if we try to do this, but also something that maybe we often overlook as part of this difficult conversations, like, but what is the danger of not doing this, and try to make that at least as scary as what you're presenting for the operation, And, you know, we mentioned earlier about something that might impact our strategy towards doing this refactor. One of the things that might affect that is performance, current performance of our database, because if your database is already sort of teetering and sort of struggling, you know, we'll talk about it in a second, but you might, if they're still umming and erring about it, it might be your job to go like, hey, look, your database is already, believe me, like it's really having a rough time, and we've identified how we can solve that. We can solve that now, or at least improve it. Or what's going to happen is one day you're going to get a phone call that God knows and say like, okay, we have a serious problem now, and you know, then it's going to be the downtime you didn't plan for. You know, it might not be off season. You know, it might be, you know, during I don't know, Black Friday or something. You know, and you know, just come out and just highlight what is the risk of not doing this. You know.
Yeah. Cool.
So I guess that's the best thing I can suggest.
Thank you.
No problem. Cool. Anything else? I'll go ahead. So yes, the last point on there is the disaster recovery plan and the or the doom and gloom that I was just mentioning there with Leo. Two things that you can see in a conversation regarding that conversation is recovery time objective, the RTO. This is just one of those fancy keywords, I guess, but that's something that might come up, and it's just talking about when you're in this difficult conversation with stakeholders, for obvious reasons, they're going to want to know how quickly could we get back to something that's at least working if the worst should happen. So that's clearly something that we're going to want to ascertain very early on in the process as we do the planning and this strategizing for this. And there's the other one, which is the recovery point objective, which is just the maximum acceptable amount of data loss during an unexpected issue in this refactoring process. So this is measured in time to say, you know, if we have a certain number of users interacting with our system in these, let's just say half an hour, you know, is that acceptable? Does it have to be less? Can we push for more? You know, just to try to get flexibility out of the agreement we have with them when we go for it, because essentially that's what we're doing really when we're talking to our stakeholders about anything, is we're coming to an agreement that like we're trying to be honest about what is the risk here, what are the risks and what are the benefits. And one of the reasons we do that is we can protect ourselves if the worst case does happen. So, you know, having this honest conversation about this is really, if everything does go wrong, absolutely everything goes wrong despite our planning, this is how much data you might lose. This is how long we're going to be down for. You know, these are very good points to highlight from the beginning, so that they can make a fair decision based on the closest thing that we have to facts available to us. And yeah, and I think we've all covered the communication being key there as well, just within that. So yep, that was a mouthful. That was the business focused side of things. Like Sebastian said at the beginning, this is going to be available later on, I think, on our YouTube channel, I think. So don't worry about making notes right now if you don't particularly want to. This will be available, so you'll be able to review this later on. So I'm sure after that dense slide, last thing you want to see is one that looks exactly the same. But so now we're looking at the technical side of things, which, you know, some of these might be obvious, some of them might not be so much. One thing that keeps coming up from the people who are more experienced of doing this kind of thing, it's like, get the baseline right. You know, if we're talking about how important it is to establish that we have business needs for this operation, you know, there's a reason that we're suggesting something that's this drastic and this risky. We need to make sure that, you know, to identify a need implies that you have an understanding of what the current day problem is. So if you haven't got a baseline backing that up, it's kind of it's a pretty silly situation to be in. You want to get a baseline, you want to know what your current state is as best as you can, because at the end of the day, when this is all done and someone asks you, hey, so that thing that you finally convinced us to do, what did we get out of it? And it will seem faster to you as the technical person on the team that deals with it every day, but you know, they don't get to see it every day. And if you have like soft metrics where it goes like, oh yeah, you know, you can feel this a bit, it doesn't mean anything. So you need to get that baseline that says, this was happening this fast, now it's happening this much. We were at this capacity before, now we're at this capacity. You know, this is how much our resources were stressed before, here we are now. And so baseline is a really big one that we want to talk about, which ties in to the second one, which is telemetry and observability. So a huge part of this is having the right tools and knowing your tools when it comes to observing the behavior and the state of your database, and you know, giving it the attention it deserves. Observe what's going on in your current state and take note of what's being stressed, what resources look like they're getting a bit short and overworked. You know, are there, you know, what's it like in our peak traffic sort of time? Where are the problems coming from? You know, and we can use telemetry and observability to not only see how much our refactoring has improved our situation, but it's also going to be super important in trying to establish this really tightly defined baseline, as tightly defined as you can get it, because, you know, we've got to kind of sell it after we've done it, after the fact that we've done the refactor. We've got to sell what we've done to our stakeholders and go like, hey, so you trusted us, it paid off, and we can show you how. We can show you how this helps you and how this helps the business. So here you go. So that's there. And downtime, or the incremental refactor. So as I was sort of hinting towards previously, you have that conversation with the stakeholders from day one to identify, you know, the business needs, why do we need to do this? And also you have that because you want to find out how you can go about doing this refactor. And that's where we are here. So if your stakeholders who are at the end of the day, they are in charge of what's going on, they're the ones that have to sign the dotted line, and they say, we can't afford any downtime. We don't want to be have any downtime at all. Then, you know, you get pushed towards the incremental refactor and vice versa. So what we mean by that is, as I've got here in the center, if we can afford downtime, as you can imagine, that means that we have the sort of advantage of being able to amend both our application code side of things and also the storage side of things, and get everything up and running at once. We can push it through our pipeline. CI/CD, we can trust in the same, hopefully we have the thorough acceptance tests that we have, and system throw all of our different testing strategies at it that we normally do, and we can feel confident through that pipeline that we normally use, that this deployment of everything is thoroughly tested, and it's going to be a good deployment, but the versioning is going to be smooth. And of course, that's a nice upside. The downside of that, of course, is going to be that it's the downtime itself, right? You know, your services are not running, they're not online, so that is the downside. If they're not happy with, if they are happy, get myself confused. If they're not happy with the downtime, beg your pardon, if they're not happy with the system going down for a specified amount of time, then, or unspecified, then the option is the incremental option, which is where you sort of have your storage half of your solution is going to be in a mouthful. It's going to be amended to sort of deal with both cases. So you're going to have your current version of things, and you're going to have your next version of things, and using things like stored procedures, you're going to implement some way that it can manage both of these versions in the meantime. And then once you apply that to your application side, you could sort of at the end of it go like, okay, have we done all the tests? This has been running long enough. We can see that everything's running smoothly with our second version. And once you're satisfied through your testing and your QA team that has been achieved, then fantastic. You can go back and you can remove that extra logic you've got on your data side. That's achieving that sort of duality. That's achieving that flexibility between version A and version B, let's call it. Now, of course, the upside is you're not experiencing any downtime. The downside is, even with little operations, like if you're going to be splitting a string. So one example I think we have later on in here is, so imagine you have a field which is simply name, and you've decided that's not a very good way to deal with that. We should have a first name and a last name. You might have a stored procedure that can identify what kind of operation that we're being asked to do here. And if we can split that name and make a first name and last name separate strings and insert that into the table we want as our sort of next version going forward. It's a relatively small operation, but if this is happening thousands and thousands of times within a small space of time, then obviously that's going to be a performance overhead on your resources. So the downside is we're going to suffer some performance issues that will, not necessarily performance issues, you don't want that, but it's going to be harder work for your database to deal with that as it goes on. And we can see what other factors are there to consider there. KPIs comes back to the conversation with stakeholders, and in a way, the telemetry and observability, and also I think the QA team as well. So this would be, this is just really a hard definition of what we want to see. Why are we doing this again? How do we measure it? And so to a certain degree, I think that's kind of self-explanatory. It's just harking back on about telemetry and observability, the importance of having a baseline, making sure that we can see that we've achieved what we want to achieve. How do we test our database? Like certain other points in this presentation, this is something that's going to be coming down to the individual use case to a certain degree. It goes without saying, you want to have a thorough testing strategy, whatever you're doing, but this can vary depending on what kind of database you have. We mentioned before about like what kind of restrictions you have on data depending on what industry you're working in, or maybe whereabouts you are in the world. So again, that's going to be a case-to-case conversation, but it is as important as any other requirement.
For breaking, Cameron, you are still on the slide 13, right?
Yeah.
Okay.
Yeah, so that's here. Sorry, I might have gone a bit off course, but yeah, we're still on slide 13. And related to that, how do we create an environment for testing our database? If we are doing it separately from our application code, then we might have some limitations there. We have to think about how do we create an environment for testing our database if we're not using the downtime option, i.e., we're not deploying everything together. You might have to come up with a clever way of how you can test that database before you've updated your application code. Backups for our recovery plan. I think that's self-explanatory there. Again, just have that conversation. How do we migrate data? Talked about that as well to a certain degree. Yeah, I don't think we need to go more about that really. And version control sort of goes without saying. Anything you do, especially if it's something that's very risky, you just want to have version control in there. So migration scripts, what have you, make sure that everything is as carefully committed and understood as far as the changes over time as you possibly can do. And I think, again, we sort of hit that baselines, telemetry and goals conversation during that checklist as well. So yeah, just, you need that baseline, and in order to achieve that, you need a telemetry, and in order to measure your goals and assure yourself that you've done that, you need that telemetry again to make sure that you've achieved what you're looking for. So that is, yep, I summed up that. Again, I've typed this out so you don't have to. You can find this on the YouTube video when this comes out. So don't worry too much about taking that down. So you've had a conversation with your stakeholders, and they've informed you that we'd rather have the downtime than the low performance because perhaps the database is already on its last legs and it's already having a rough time. And if you apply more stress, you're going to have downtime anyway, but it's going to be, involuntary. It's going to be when you don't want it to happen. So yeah, it might be preferable. So you can just take it down. And like I said earlier, you can take advantage of that infrastructure you've got already. The test pipeline, you've got a thorough testing strategy there. Deploy the new application code with the new database, watch it all working together with those tests to make sure everything's sorted out with the acceptance test, etc. Get it deployed, QA, check it all out. And this is a deployment like you're something that we'd be more used to in a nutshell. So there's that option. But then your stakeholders might say, we'd rather have the load forwards than downtime. So maybe this is a very critical system. They don't see it as being acceptable at all, that it goes down at all. We can work around that requirement by using a rolling or incremental refactor. So you might have several God knows how many tables. You might have several tables there, and you just focus on doing this one particular schema. And earlier we mentioned this naming convention where in version 1, let's say, you had a name field. In your new version 2, you want to be using a first name and last name. So what we want to do by using tools that we have on the data storage side of things, like stored procedures, what we're going to do is, without touching our application code, what we're going to do is we're going to have a way that allows us to accommodate both V1 and V2. So you can think of the intermediary step as like a 1.5, if you like, on the data storage side, something that's capable of handling both the requirements just whilst we make this gradual change. And then once you've got to the point where your application code has been updated to meet this V2, make all the necessary checks to make sure that everything is working correctly. Once you're confident with that, then you can remove that extra burden from the database side of things, remove that stored procedures, whatever it might be, and get back to your normal, hopefully improved database state. So yeah, so that would be the alternative there. So the next section is testing.
Okay, guys, do you have any question before we go for testing strategies?
Yeah, cool.
Yeah.
Cool, okay. So testing. So yeah, I mentioned at the beginning that there are sort of parallels to when we talk about refactoring our code base and refactoring databases. Again, we depend heavily on our test helpers maintain the integrity of our system, because that is, at the end of the day, that's what's measuring the input and the output. So that is goes without saying, is extremely important, also even more so than usual here. So we've got our test pipelines, as we always do, checking that all expected functionality works end to end. Sebastian said something interesting to me yesterday whilst we were talking about this subject. He mentioned, like, a lot of people forget that, you don't need to have a pipeline deployed there if you don't want to. This is your tool to do whatever you like. So you might have a pipeline that's just to make sure that your new, that your database, that particular repository you've got, just to make sure it works. You can do that, and then you can make sure it works, and then you can go back to your stakeholders and say, cool, I think we've got this situation where we're confident that we're ready to go. When would you like to? So, really take advantage of those pipelines and use those as you normally would do to feel confident about the integrity of what you've done with your database. QA involvement. So there's a great deal. You just need to have them throughout as well, and make sure that everything's working as best as it can be at any time. Testing strategy, again, this is very individual to the particular business use case, but just have the focus on it, but it needs to be thorough. And the performance testing. We hopefully, at the beginning of the conversation, we used our tools and our telemetry, our logs and things like that to identify what our baseline was. And when you get towards the end of the process, you could use that to see if you've achieved what you want to achieve. And also, if we're going for the incremental refactor, we can use that in the interim to see, we're expecting this extra stress on our resources whilst we're doing this rollout, this incremental refactor. Like, how is it putting up with that? Is this under more stress than maybe what we thought it was going to be? Just try to monitor the situation, make sure that there aren't going to be any nasty surprises whilst this process is going on. So regarding the pipelines and your options here with the downtime versus the incremental refactor option, the downtime option, because you have that advantage of being given, you've been given the go-ahead that you can actually take things offline whilst you do this. You can make these changes to your data storage side and your application code in unison with each other simultaneously. Then fantastic, you can just push them through the pipeline as you would do with deploying a new project, for example, and you've got all your tests there to check it out, so it's fine. The issue is it gets to something a little bit more tricky if you're doing the incremental refactor option, where you've got your your data storage side it's getting to that sort of interim point where you're going to get it to facilitate both your current version and what you're hoping to get to. That's going to be in its own repository, if you like. And when that goes through its own testing procedure, you might not necessarily have previously thought of a strategy where you can test that when now that it's been sort of isolated from the application code. So you would have to get together with your technical team and decide what the best way to do this is. One way that you can do it is if your application code is containerized, you can use that image within the pipeline for your databases repository and use that as your sort of testing mechanism, where you can have that throwing request at it and make sure that that's all working at the very least. And you can sort of reuse that carbon copy of your application code, if you like. If you don't have access to that, then you're going to have to build some kind of tested environment that will satisfy some requirements. That's going to be a bit more work, but again, like you mentioned at the beginning of the presentation, that's going to be something that's going to be so involved in the individual use case that you're doing this for, the individual business case or organization. So that's going to be a conversation around your dev team around what is required and how can we quickly and best get that sorted out. And I've got to the point where I feel like I've recognized that this has come up an awful lot, but yeah, get that baseline. Make sure that you get that baseline first, because it's going to, not only is it useful for you and the rest of the technical team that are doing this, and of course, making sure that nothing disastrous is happening as the process is being it's been worked on. But people do want to see metrics, like hard metrics, especially when they invest in a decision that's so risky. So get that baseline first, measure what's going on, get some hard numbers in there, and then that gives you a good comparison for when you want to assure that everyone vote the decision to go ahead was the correct one, and that you've managed to get the results that you're looking for. So this is just I've completely forgotten the name of this tool, but Sebastian, what's this? Grafana, I think it is. Is that one? Yeah. This is just a shot of Grafana to show, what kind of dashboard, what kind of tools you'll be using, and what kind of numbers you could be looking at to ascertain how your refactor is going. And that's it. So that is hopefully some a universally applicable strategy for looking at refactoring databases. And there we go. So if there are any questions now, I know you haven't had any for the most part throughout, but if you do have any questions, then we can go ahead and have a shot at them.
Nothing?
No?
Right? Like, first time, nothing. Second time, nothing. Third time, nothing.
Oh,
Mateus.
Yeah, just a sec. Sorry, I was about to write down, but it's easier if I ask. So yeah, I really the last bit saying about the testing strategies, I think that they were like really nice. So I don't know if you have any advice for, because you mentioned to maintain like the new version and the same version at the same time as a strategy, right? So for that, then would you recommend to test how to proceed with the testing for those two?
Mm-hmm. But you mean version of the database or the version of the application?
The database. The database. Yeah.
Mm-hmm. Well, like in this case, it depends on the situation, because you might have situation that you need to support two different versions of the applications. You're creating intermediate migration of the database schema to support both of them. Like the example that Codurance give you, that we have the name of the customer, which is surname, first name in one column, and suddenly you need to break this, and you want to support both application versions at the same moment. What is important if you're doing migration like this, that you want to support two different operations, what we find out in one of the projects is to double test all the migration backwards and forwards, because something that sometimes is missed during planning for that, we're checking only if we can migrate forward safely. But what if we need to do a rollback? And we forget in the rollback migration to clean up the data or clean up stored procedures, triggers. So one of thing is actually what we find out was sufficient in one of the pipelines that we built for one customer was that we were starting with a container in the pipeline, Postgres. We're applying migration from beginning with a seed of data, all the migrations forward. Then we're rolling back all the migration to zero, reapplying them again to check if the second application doesn't leave traces in the database, rolling back again. And after third successful apply migrations in the pipeline, and everything was fine, we didn't have SQL errors. Only in this case, we were sure that actually we every time cleaned up resources correctly. And we still were checking with SQL queries against the container. If the data keeps the integrity, we didn't lose, the records are count is correct, and all the data are in the proper place. So double check migration in both direction, actually, how you tearing down and how you're building the schema, because there are some nasty surprise down the way sometimes that we didn't foresee. Yeah.
Cool. Did you mean to put your hand up again, Matthias?
Yes. Hey,
Yep,
sorry,
okay.
I'll have another one. Second one. Sorry for. And then you also mentioned, I think it's a really nice monitoring system. And my question is, this was like specifically to the database, like metrics specific to the database, or it was also like other things that depends on the database, for example, like the application, if the application is still like behaving as it should, like as if it was like, as if it were like an end-to-end test or something like that.
I think that particular image was just monitoring the database, but there's no reason you can't have telemetry looking at how is this going end to end from your application as well. You know, if you do have telemetry already in place, hopefully that's, you know, measuring how long it might take to perform some kind of operation, then of course it's great to use that as your baseline and say like, okay, so this is the average, but this is the average amount of time it takes for us to, I don't know, add a new customer to our database. And then after you've done everything, you can look at that same telemetry again and go like, hey, look, we've got this improvement. Fantastic, you know, and you can report that and sort of objectively say that there has been an improvement made there. So yeah, that particular example was just database side, but there's no reason to not include telemetry end to end for looking at a general improvement and how we can measure that. Cool.
Okay, anyway, any other questions?
All right.
Okay. Come, I have a question for you.
Okay, go ahead.
About the engagement actually of the QA team in planning the testing strategy. What you can tell us about this, because as database is crucial for every business, like our application, the only purpose of what we're building is to process data and store them somewhere for later. This is the heart of what we are doing, data and information and persistence of it. So how we should approach testing this with QA and why they should be involved in the process?
Well, first of all, I guess the QA team is going to be, hopefully it's going to be a team that's very experienced with, you know, their whole role is to make sure that things are working as they should be, you know, so they're going to be an invaluable point of conversation when you're actually planning, how do we ensure that this has been done correctly? So part of it is the experience of, and explain some of what they do to you when they plan it, and you can go to them and ask, you know, what would you consider to be a good strategy, as you're the team that have to be involved in this day to day. So yeah, I think they are a good resource because that's what they do and they play an important role in it, and they will have some insights into how to test and how to ascertain that this has gone correctly. I think really the approach we were sort of looking at there is, because it is something so big, you know, the bigger the operation, the bigger the group of, you know, stakeholders you want to get to sort of talk to about it, so that they have they get their heads up and they get their sort of warning this is going to go on, but also because they are the source of information that you need to understand a lot of these things. So, for example, we were talking about non-technical stakeholders with knowing, you know, how do they feel about downtime, or when would it be a good time of day or a good time of the year to do this if it, you know, it's a particularly risky situation. And so in the same way, I think each group of people, when you talk to about this, they have their own influence on how it's going to work out, and they have their own knowledge that perhaps you don't have as a dev team, you know. And in this case, the QA team, because they're sort of specialized in that, it's kind of like the same reason, you know, we always say that if you have a team where you don't want to develop a tested a feature, but that same developer has built, you know, for obvious reasons, because you can develop your own blind spots and things like that. I think it kind of comes under that as well, but you want to have a sort of, I don't know if objective is the right word, but you want to have a separate set of eyes, a fresh set of eyes, a fresh perspective, investigating how is this done, because, you know, it's not they haven't done it, so that they're sort of they're separated from the responsibility of having done the work, so they kind of have a fresh perspective of how to test it, I think. And, you know, so yeah, I think you get them involved for the same reasons that a lot of development teams see the value in having testers who weren't involved in the development process. You want to have that fresh perspective, especially when they're experienced testers, you know. So yeah.
Cool. Thanks, man.
No problem.
Okay. So, any questions? Other?
Yeah, I guess I've got one about specific testing strategy in terms of you know, Live's a great set of data for testing. When I want to test against the data set in a staging environment or in dev, what have you found to be a good way of producing that data? Is it entirely copying? I'm sure it's contextual, but do you have a general approach to this with just copying over all data or a subset of all data back to a certain time, generating that data through some manual process, or as in, yeah. Anyway, how do you derive data to test against for testing database things?
From our experience, it depends, like mantra, because if you got really complex legacy system that might have tons of store procedures inside, views and indexes on top of it, it might be difficult to like copy those data. If your database already is terribly huge, it might be difficult. One of the approach, especially if you're working with the cloud, most of the cloud vendors allows you to do a snapshot of the data at the specific point in time. Cool. And you can just clone the database for testing purposes from the moment you are on with the fresh data if it's complicated setup. If you have possibility to use factories and seed the data set with isolated examples and you don't have really complex relations and query, this is also a viable option. It's a lot depend on the context, because sometimes you have so heavy operations, so complex databases that it's almost impossible to seed them by yourself without long manual process.
Right.
So it's all depend. We also sometimes have situation that we think that database should be in valid state always. We're going for testing or pre-production staging environment. We're finding out that data is invalid inside the database, and this data is there for years and no one even realized that because it was so complex set. So it's difficult and depend on the complexity of the project. Okay. Sometimes preparing testing strategy and talking to business before we even touch planning for migration might take months to establish the baseline, capture information that you need, actually get the objectives, why you're doing this and how to measure this, how to do it safely, and set up a safe environment for testing. Sometimes it might be a long process before even you start coding migrations and refactoring. It might take months to get all this in places, especially with big organization corporation that's moving slower and they're not as dynamic. Yeah, Mateusz?
Just came to mind another question that is, we're talking about migrations, and I'm used to like using migration for regular applications, like as number one. So my question would be, those refactorings in the database, would you like use the same migration system as the application that use the database, or would you like set up something totally different and a pipeline totally different? Like, extract away this process of refactoring the database with actually the applications that consume the database.
John, you want to pick this up?
I think you've probably got more experience with
Okay.
that side of things, to be honest, Sebastian.
I think it's safer actually to introduce another tool for at some point to start controlling database migration, because our database does not have the same life cycle as applications. And if we tied our migrations heavily to, I don't know, Hibernate, entity framework, we have also Eloquent from Laravel and PHP world. If we tidying ourselves this heavily to application, we coupling application lifecycle extremely with the database's changes, which might be dangerous and might actually stop us because, for example, we cannot do parallel change on the database. We cannot support both versions at the same time without redeploying the whole system again. And maybe we don't want to redeploy everything because it might be slow, long-term manual process. So it's safer to decouple yourself and introduce third-party tools, especially that then you can test the migration in isolation without bringing to the table all the application logic, which, as we know, if we're following clean or hexagonal architecture, this should be decoupled. I'm not even talking about domain-driven design that, let's say, database representation and storage is completely different how we operate in Sarah core domain.
Okay. Well, that's
Any
it.
other questions? Anything we can help you with? No question first time. No question second time. No question third time.
Cool.
Okay.
Great.
So thank you for being with us. Thank you, Cameron, for presenting and delivering today's presentation about preparing for migration and how to do it. We are happy to have all of you here. Thanks for the question and hope to see you soon again. Have a great afternoon or evening, depending on the time zone. And yeah, till the next time. Thank you.